The mathematical expression shown here, 2 plus 3 times 4 minus 7 squared, is not a particularly difficult one as mathematical expressions go, but I'm sure that each of us in our history of learning how to evaluate mathematical expressions have made errors on expressions just like this one. And I want us to take a moment to analyze why people may often make mistakes in evaluating expressions like this one, and why a computer might also have a difficult time handling expressions in a format like the one shown. So if we consider that most of the time when we've processed things with a computer in our programs, we have processed things one character at a time. And really, that's all we know how to do in terms of we have to have somewhere to start. We look at a particular piece of information there, and then we expand out from there. Whether it's from start to finish or starting in the middle or wherever, we have to start somewhere, look at a next thing, and so on. So in this expression, if I tried to evaluate it one character at a time, skipping the spaces, then what could go wrong? What would be difficult about doing that? So pause the video, stop and think about what could go wrong, what would be difficult about evaluating an expression like this one. And there are multiple pieces to that. So if you think you have one, think a little more. Pause and think. A couple of aspects that might have arisen for you in thinking about this are that we can't do any math right away when we see, for example, 2 plus. We have to wait to see the full expression or the full operator and 2 operands before we can do a binary operation like plus. So we have to wait to see the operator and both operands for plus, minus, times, and division. So for a computer trying to get one thing at a time, there's going to need to be some storage, at least temporarily, to know, okay, I saw 2, I'll hold on to that. I saw that plus is what I'm supposed to do. What am I supposed to do it with? And then even just looking at that example of the 2 plus 3, thinking about common errors that young students in particular make when they see an expression like this, they would add 2 plus 3. And that would be incorrect right away because order of operations applies as well. There's precedence between the different operators that are happening here. Squaring something, doing multiplication, and then addition and subtraction. And that order of operations is difficult for people learning it and is also difficult for a computer trying to process through an expression like this one. So order of operations or precedence between operators can cause issues as we read through item by item, token by token, character by character. Order of operations or precedence causes issues as we read one character or token at a time. People will often refer to the items in a mathematical expression or in reading in content as tokens. Now, all that said, this particular type of notation is very useful for humans. We find it very readable to see 2 plus 3, for example. But for computers, we're not tied to that notation. And so this notation up above is called infix notation, such as 2 plus 3 or 3 times 4. In computing, we'll often find it very helpful to use another notation called postfix, which is where we provide all the operands, like 3 and 4, and then the operator. So in infix, operator goes in between the operands. In postfix, the operator goes after or post the operands. And what you may see as you work through some concepts around this is that when we have an ordering where the operator goes after the operands, we store up some data and then we learn what to do with it. And if we continue in that same sort of scheme, then that will make the computer's job much easier. Store a small amount of data, learn what to do with it, do that operation, and continue. And as you start to dig into Postfix more, you'll see how its representation of even more complicated expressions like the one above, or ones even more complicated than that, can be very helpful to a computer in processing through mathematical expressions. And you'll do that today by looking at sections A and B of the Postfix activity. It's not absolutely critical today that you finish part B. A great position to be in would be to have a little deeper understanding of infix from section A and to start to understand how postfix is used in section B. But it would be great to come into the next class session with some questions and some reference points to dig deeper into postfix. So jump into activities section A and B. Good luck.